you very much. So my name is Federica Di Palma. I'm the Chief Scientific Officer and the Vice President of Research and Innovation at Genome BC. Thank you, Zsuzsa, for the acknowledgement. I'm delighted to welcome you to this first webinar of our new data science series. Genome BC recognizes that sharing, managing, storing, standardizing, and of course, analyzing and integrating data is absolutely critical to our mission to accelerate biological discoveries, as well as better health and environmental outcome. To maximize the value of the data that are generated through our Genome BC funded program, in 2021, we launched a data science strategy at Genome BC in a aim to support our ecosystem to provide a roadmap to better accelerate and modernize the data science in our ecosystem. It is a pleasure to introduce to you our data science lead, who was hired to refine and implement such a strategy, Dr. Zsuzsanna Hollander, and who also is the force behind this fantastic webinar series. Welcome, over to you, Zsuzsanna.
Thank you, Federica. We are really happy to start with the FAIR seminar and Dr. Mark Wilkinson. But before I introduce him, I wanted to mention that the next webinar will take place on January 12th and will focus on indigenous data governance. And then in March, we will all collectively learn about the WHO guiding principles for pathogen genome sharing. More detail will be provided on our website over the next few days. And now back to Dr. Mark Wilkinson, who used to be a colleague of mine many years ago, but now he's a BBV UPM industry chair on biotechnology and an ISAC payroll distinguished researcher at the Universitat Politécnica de Madrid. His research over the last couple of decades has focused on the problem of enabling biomedical researchers to execute their own data manipulation and analysis. While at the University of British Columbia about a decade plus ago, he created the BioMobi semantic web service that is an interoperability framework, which at its peak included more than 1,600 bioinformatics data sources and tools. He also created SEDI, a set of design practices that enhance interoperability between semantic web services, as well as SHARE, a novel query resolver that combines the workflow engine with a logical reasoner to dynamically generate and execute a data retrieval and analysis workflow in response to questions posed by users. In this webinar, he will discuss the FAIR guiding principles, a set of guidelines that simplify the discovery and reuse of scientific data, which has been his passion project for the past several years. And with this, over to you, Mark.
Thank you very much, Zsuzsanna. Thank you for the invitation. I'm very honored to be the first speaker in this series. So I'm going to share my screen, and I might switch off my camera if that. Zsuzsanna, do you mind if I do that?
That's totally fine. And
okay,
yeah, just reminding the attendees that Mark said that if you have any questions, please do interrupt in the middle of his presentation. He's happy to answer them as the questions come.
Yeah, so I guess you have to put the questions in the chat. So Zsuzsanna is going to alert me if there's chat questions. So here is the barcode that will lead to the presentation. And there's a link down here, should be easy to remember, FAIR GBC. So today I've been asked to talk about FAIR, and I'm going to tell you sort of the origin story of FAIR. There's some misunderstanding about how it started, and there's some misunderstanding about what the principles mean, and even about the number of principles. And then we'll go through, again, Zsuzsanna has asked me to talk about things like determining if you are fair, how do we measure fairness, and how are we thinking about governance of fairness. So that's the overview of what I'm going to talk about. So I'm going to apologize. This presentation is intended for you to reuse, and I would like you to be able to reuse it without having to remember my voiceover. So there's a lot of text slides. In addition, because I work on metadata, there's not a lot to show you because it was never intended to be seen. So I have to describe what's going on in the background. So where did FAIR begin? And where do I fit in FAIR? Well, the history of FAIR is really the history of Dr. Baron Mons, who's been a friend and colleague of mine for about the last 18 years. We first met in 2003 at the Oriol eBiosci meeting in Verena. The title of the meeting was Dealing with the Data Deluge. And at that point in our careers, Barend was working on indexing concepts in biomedical text to improve search. And I was studying indexing structures of biomedical data types to improve interoperability. So you put concepts and structures together and you get very rich semantic behaviors, which is what we then tried to do from that moment on. The following year, so just 1 year later, the World Wide Web Consortium recommended both RDF and OWL as semantic web standards, semantic web recommendations, sorry. And the tooling to build these infrastructures started to become more commodity, and the energy and enthusiasm began to grow. In May 2009, Barend invited me and my student at the time, Ben Good, to become magnet group members of his new initiative called the Concept Web Alliance. And the idea behind Concept Web Alliance was to remove redundancy and ambiguity from available knowledge to maximize knowledge discovery. And then we get to FAIR. So in January of 2014, Barend hosted a workshop in Leiden in the Netherlands called Jointly Designing a Data Fairport. And let me tell you what that was like. So he had an analogy that was the basis of this meeting. And at this point in the history, the acronym FAIR didn't exist. So FAIR in this analogy actually meant fair, as in lowercase fair. And his analogy was this, that people are data and planes are data users, both human and machine. So the planes data users are both human and machines. Planes routinely collect the correct people from the correct place with very few errors. Passport control ensures that people only go where they're allowed to go. And this happens reasonably transparently to the airline. And any airline can pick up any authorized person from any airport. And all of this happens with almost no friction. And so he proposed that if we can do this on a global scale for people, why can't we do it with data? So at this unconference in 2014, there were 31 attendees, approximately, representing a wide range of stakeholders from research infrastructures to policy institutes, publishers, technology specialists, innovators, computer scientists, and experimental scientists. And the discussion revolved around the context and user needs and technological challenges, business models for making it last indefinitely, hopefully, funding requirements, and governance of a global initiative around data reusability. And all participants agreed that professionalism was absolutely required. This was not going to be what Barend refers to as professorware. This had to be high quality, robust, professional, with a professional business model behind it and professional governance behind it. And that was the only way it was going to have any impact on the world. And at that meeting, we had a set of about 30 core requirements, and Barend subsequently coined the acronym FAIR when he separated the core requirements into categories of findability, accessibility, interoperability, and reusability. So briefly, findable is unambiguous identifiers supported by searchable metadata. Accessible is clearly defined access protocols, preferably ones that are actionable by machines autonomously. Interoperable is the use of shared vocabularies and ontologies, again, preferably in formats that are completely machine accessible. And finally, reusability is the availability of contextual metadata that allows proper interpretation of the data, and rich provenance metadata that allows accurate citation of the data. The beta edition of the 15 FAIR principles was published on the Force 11 website because of their strong involvement in research communication, and we got feedback from the community on the principles. In parallel with that, at the Biohackathon in 2015 in Nagasaki, Michel de Montier, now many of you will remember his name because he was with the Blueprint Project back in his early days in Ontario, in Ontario, right? And I, together with Mark Thompson, Nick Juty, Gang Fu, and Jurgen Bowman, worked to further refine the principles into their final version, which was then published in 2016. And after that, things happened very, very quickly. So the world had already started to hear about the FAIR principles for 2 years. So when they became published in 2016, there was already an expert group advising the European Open Science Cloud on how they should establish the cloud. And one of the quotes from that document is that adequate data stewardship should be mandatory for all research proposals. Horizon 2020 should only support projects that properly address data stewardship, and those that do not specify FAIR conditions should not be eligible for funding. Right. Now, that's a very strong statement. Caught a lot of people by surprise, you can imagine. But they continued. So in the guidelines for FAIR data management in their open research data plan for Horizon 2020, they put FAIR, you can see, at the center of their infographic about what their plan was for research data management Europe-wide. Again, in 2016, the European Commission statement from the G20 leaders communique at the summit was, we support appropriate efforts to promote open science, facilitate appropriate access to publicly funded research results on the basis of findable, accessible, interoperable, and reusable FAIR principles. And in 2017, France, Germany, and the Netherlands established the Go FAIR network, which is a network of FAIR supporting coordination offices, which was the beginning of the professionalism and the governance issues that we knew had to come into effect. So let's talk about the principles themselves. I would imagine that there are some or even many of you who've never seen all of the principles written. So I'm going to go through them one by one. And if you have a question about why one of them was written the way it was, please put your question in the Q&A, and Susanna will stop me and I can discuss it immediately. So, principle F1. Now, when we say meta in brackets data, it means that the principle applies equally to both metadata and to data. And so here we say metadata has to be assigned a globally unique and persistent identifier, and that is simply so that you identify everything that is worth identifying, and you give it something that's persistent and unambiguous. F2 says that data are described with rich metadata, which is partially defined by R1, but not entirely defined by R1. That is we're in the findable. So in the findable, this metadata is for the purpose of discovery. F3, metadata explicitly include the identifier of the data it describes. Now that is a weird one, and I'm going to spend just 30 seconds explaining that. In the context of digital objects that are not web pages, it's difficult starting from the digital object itself. Let's imagine it's an image or a movie. How do you discover the metadata of that image or movie? And especially because metadata can be separated from data on different servers even. So we said, well, if you have the identifier of the data in the metadata, you can do a search for that identifier in order to discover the metadata document. And so that is why this principle exists. It's to allow you to start from the data and discover the metadata rather than the other way around. I'll show you later how we've now found a better solution to this problem. And finally, F4, metadata are registered or indexed in a searchable resource. So you have to be able to search this metadata. Accessibility, metadata are retrievable by their identifier. Now, notice we say retrievable, not resolvable. And I'll explain that in a moment, using a standardized communications protocol. We didn't say resolvable because there are some data
Mark, we can no longer hear you. Maybe you can switch off your camera.
Protocol. I dropped off for a moment. Let me try again. So I don't know where I dropped off, but I'm in the A's. So we'll carry on. So A2 is that metadata are accessible even when the data are no longer available. This is really important. 20 years from now, if you look at a paper and that paper refers to a data set and that data set no longer exists, you still want to know what that data set was about. And so we try to emphasize that metadata has to have a longevity longer than even the data. Interoperability is about the use of formal, accessible, shared, and broadly applicable languages for knowledge representation. Again, as much as possible, they should be machine actionable. Metadata uses vocabularies that themselves follow the FAIR principles. So we would like people to use ontologies where the ontologies themselves are FAIR. And this one is tricky. Metadata include qualified references to other metadata, meaning that when you point outwards from metadata to some other concept, you should explain why you are pointing outwards to that concept. So that's what we mean by qualified references. You don't just link to something, you link to something with a named link, explaining what the relationship is to that other information. Now we're on to the R's, metadata. Yep.
Sorry.
Go ahead.
There is a question. Can you please touch on the retrievable versus resolvable nuance? That's where it got cut off.
Okay, so we'll go back here. So retrievable versus resolvable. So we do not require that data can be resolved over the web using the identifier, because there are some data that will simply never, for privacy reasons, for example, clinical data, will never be resolvable over the web. It's simply not legal. But there should be a way to get hold of that data based on its identifier using a standardized communications protocol, including telephone. Right? If the provider says the standardized communications protocol is telephone, then that's the protocol, and it is perfectly acceptable to FAIR. So FAIR does not mean open. And so that's why we say retrievable rather than resolvable. We're in the R's. Now, this one is also a little bit confusing. So metadata are richly described with a plurality of accurate and relevant attributes. Plurality, giving credit to the author of that word, that was Michel de Montier, who came up with the word plurality to find a way to describe that you should be as generous as possible when you describe your data. So you should be as generous as possible. Give more than you think you need when you're creating metadata. Metadata are released with a clear and accessible usage license. This is critical. Companies will not touch data that does not have a license because they don't know what you're going to do to them if they use it and suddenly you claim a license. So you have to have a license or your data is unusable. And finally, not finally, metadata are associated with detailed provenance. So where did the data come from, using what algorithm, from what organism, using what protocol, and so on. So detailed provenance, explaining the meaning of the data. And finally, the catch-all at the end is after you've done everything else, if you have community standards above and beyond this, you must meet those also. So the key messages of FAIR is that it aims to improve and simplify accurate data reuse. FAIR is 90% or more about metadata and maybe only 10% about data. FAIR data is described by rich contextual metadata to ensure that other users can fully understand the content structure and how and why it was created. Rich metadata uses controlled vocabularies and ontologies to ensure that it can be interpreted by machines. And rich data uses metadata uses machine readable structures and open standards that allows it to be processed by machines and easily reused. So let's move on to the question, how do I know if I'm fair and who gets to make that decision? So now I'm going to include the work of these fine collaborators here that I won't read, but you can see, scan their names. So we're now looking at examining the maturity of fair records. Now, this is important. Fair, although the word is lovely, fair is not just a fuzzy feeling, right? So in the paper, we say, this necessitates machines to be capable of autonomously and appropriately acting during their self-guided exploration of the global data ecosystem. Right? So fair is not just a feeling, it is a behavior. And therefore, fairness is measurable almost by definition. Right? So if you're going to create a web of data that can be intelligently reused by machines, we must have certain behaviors that is exhibited by that data. Those behaviors must be concretely described because we're going to be designing software around it. And that software will then utilize those behaviors to find access and reuse the data. If that's true, then we can also write software that examines a given digital entity to measure the degree to which it exhibits those behaviors. Can the machine find what it wants to find?
So before you go further, there was a question about there is a big world of various levels of free use licenses out there. Any recommendations, preferences for licensing your data?
There is absolutely no recommendation at all from the principals. Okay. Because different communities will have different requirements, so we can't generalize around a license. And in fact, the reuse of clinical data includes consent, and the consents are often localized to a single research institute. So we keep well away from that, and we just say you have to make it available and transparent. But you cannot publish data without it. That was the only rule. So there was a founding metrics authoring team of the 6 of us here you see on the screen, representing a wide range of different professions, so including journal editors and data archiving experts. And after 3 face-to-face meetings in over 6 months, we successfully created exactly 3 metrics, and we weren't even very happy with those. It turns out that inventing metrics is extremely difficult, especially when it's done by a committee. So Michelle and I, being friends and longtime colleagues, we met up at the 2017 hackathon, and we decided to simply design them ourselves. Smaller committees, more metrics. So we got to 14 fair metrics, spanning the full range of principles, except for the last one, the community standards.
There is one more question, sorry to interrupt, Mark.
Yeah, go ahead.
Are these principles applied when you put data on networks or while you perform a research project?
Or while you perform, that's okay. Do you mind if I leave that until the end?
Sure.
Because we'll be talking explicitly about that at the end. Okay. So we published this paper on a design framework for fair metrics, hoping that the community would start to design additional ones. But I want to talk about these generation 1 metrics and show you what one of them looked like. So the example was the identifier persistence metric, and you have to provide a URL to a document describing your persistence policy. And the test was, does the URL resolve? Right, now that's incredibly weak. Right, so the URL could be the URL to your mother's apple pie recipe. The machine doesn't know. The machine simply tested, does it resolve? And it trusted you to give it a URL that actually described persistence. So these generation 1 metrics lend themselves to questionnaire style interfaces, questionnaire style interaction with data producers, and it raises awareness. So this is useful, it raises awareness in their minds about what has to be considered when creating FAIR, but they can be minimally validated. And when we sent out these questionnaires and we received the responses back, I manually went through all of the responses, manually went through the resources that they were describing, and I found that I disagreed frequently with what the providers perceived about their own fairness. And so it became clear that questionnaires are subjective. Answers are based on misunderstandings, beliefs or opinions that may or may not be true, or mischaracterization of their own behaviors. The scoring system ranged between 0 and 1, so between 0 and 5 stars, but the selection of the score was subjective, so that wasn't very useful. And there was no way to interpret a partial score. What was the difference between a score of 0.25 and a score of 0.75? There was no way to interpret. So there was a lot of weaknesses in that approach. Technical failures, questionnaires don't scale. They're time consuming, and more importantly, they're time consuming because they can only be executed by the person who knows the resource deeply, and that's often the busiest and most expensive person on the team. Right? And most importantly, they don't adequately test the main point. The point of FAIR is, can a machine find and reuse the data? Asking a person that question doesn't get us anywhere. So going back to the statement, this necessitates machines to be capable of autonomously and appropriately acting when faced with a wide range of data types, formats, and access mechanisms protocols that they're going to find. Now, the community pushed back and said, we existed before FAIR, so judging us at all is unfair. So we had this soul-searching moment because there was actually some considerable anger and frustration in the community. So perhaps we should not do evaluations at all. However, we were under pressure from journal editors, agencies, and so on to provide mechanisms by which FAIR adherence could be measured because they wanted to require fairness. So publishers wanted to require fairness of the authors, granting agencies wanted to require fairness of their grantees. So the provider of data would say, well, our resource is fair, and the agency was stuck saying, well, how do I know? How can I know that? So we have to build an evaluation system. So we built the Generation 2 FAIR maturity indicators, which ask the question, what do machines see? Non-technical challenges, we changed the name from maturity indicators to from metrics to maturity indicators because it sounds less judgmental. We started to emphasize community-driven FAIR evaluation, so getting the community to decide how they should be judged, better documentation, more objective because you're now using a machine, so you don't have any subjectivity there. And we wanted to make sure that the output of the evaluation was not just a score, but in fact something that helps you improve. I'll skip through because we're running a little slow. The idea was that we're going to build an exhaustive metadata harvesting library, and it in fact pursued paths that I don't personally consider to be fair in spirit, but I'm trying not to be prescriptive. So I built this with the idea that I would let the community tell me what they were doing, and then I would use that to judge. I would use that approach to judge them. So the metadata harvester is quite complicated and it's a little bit geeky, but the idea is that we have a variety of different kinds of identifiers that we can start with, DOIs, handles, URLs, and INCHI keys, and they go through a process of attempting to discover metadata using a variety of web techniques, including what's called content negotiation, trying to find where the metadata might be, and sometimes it goes through this process dozens, 20 times trying to find it. And finally, you end up with something that is metadata, structured either as structured data or as linked data. And you put that into a repository, and there are various points in this where we store it in a repository. And that blob of metadata contains all of the hash styles, so key value pairs, all linked data, so semantic structured metadata, and also the raw output of every call from the web. And that is then the substrate for the individual tests. So the tests themselves are standalone web interfaces. You can execute any individual test by calling its interface. The tests can be written and published by anyone. They gather metadata using my harvester, and then they test that harvester output for various features of interest. So for example, Generation 2 maturity indicator, which is looking for the data identifier in the metadata, it looks for a hash key or a linked data property from a list of widely used properties that point at the data, including, and I'll show you on the next slide, all of the properties that we search for. So we say code repository, main entity, primary topic, and so on. Information artifact ontology is about, and others. So we are fairly flexible in which vocabularies are acceptable to FAIR. The output is not subjective, it is just pass-fail. Can the machine find it or not? Partial scores were too arbitrary, so we return binary pass-fail. They also log, the tests log everything they do so that the output contains a complete record of exactly why the test passed or failed. And the point of the test is to encourage incremental improvement. And so we give this detailed feedback not only to be transparent, but also to be supportive and informative. Again, designed for community-driven evaluations, anyone can create a maturity indicator, and we will then go through a vetting process, a peer review process. And then all of those came together in what we call the FAIR evaluator, which pipelines these individual tests into strings of tests that are decided by a particular community. So the evaluator provides a human and machine accessible interface for registering new tests and maturity indicators, registering community-specific or domain-specific collections. So you decide in your domain, these are the tests that are applicable to me. Executing those tests, which is the application of a collection to a specific ID, and searching for collections and so on based on keywords. This is what the interface looks like. The link is up here. It might be broken today because our security certificate seems to have expired, but only in some cases. So I'm not sure it works today, but I'll fix it tomorrow. It's extremely open. So anyone can execute an evaluation on any ID. They can select any set of maturity indicators they wish to apply. So journals can select a journal-specific collection, and funding agencies could select a funding agency specific, but people could also apply collections that are inappropriate for that data resource. And in hindsight, because it's completely open, that might have been a bad idea because it leads to embarrassment and frustration by people who feel they're being evaluated unfairly. I won't go through this workflow, you can look at it yourself. This is what the output looks like. You have a overall score shown by this ring, and then you have the individual outputs from every test, and a green indicator pass and a red indicator fail. And if you open up that, you see the full provenance trail of exactly what the test did to try to figure out if you were compliant with that principle. And in the end, here we see that was a success. Here we find a failure, that a persistence policy was not located in the metadata. The next version of the software, which I'm working on right now, instead of outputting this, which is a little bit geeky, we're going to output a narrative advice on how to fix the problem rather than simply pointing out the problem. So stay tuned for that. The evaluator, the next generation evaluator, is going to tell you how to solve your problems. Usage, it's quite popular. We've had about 8,000 evaluations using the public version. I have a private version in my company, which runs about 10 times faster and allows some other nice things, including privacy. We've had several thousand evaluations run on that. And execution of individual tests, I don't monitor at all, but I know that individual tests are being embedded in third-party software and workflows, and those individual tests are being run on a fairly regular basis. Now, I show this to lead into the downside of all of this. We have generated a cottage industry. So fair assessment suffers from abundance. As of yesterday, there was a new one yesterday, there are now 22 independent fair assessment platforms. Most of them are questionnaire-based, but there are several automated systems similar to mine. Unfortunately, the outputs cannot be compared to one another. Now, I think the fact that there are so many being built shows that the community is clamoring for a solution, right? Everybody wants to know if they're fair. And it seems that in some cases, if you don't like the result of one, you just build your own. So how different can they be? Well, this is a comparison of my evaluator with another automated system called Fuji. And we're examining the same record. So this is a catalog record in the Duchenne muscular dystrophy clinical registry, represented through a FAIR data point, which I won't describe. And so here's the score from my evaluator, 20 out of 22 tests pass. That's actually the highest scoring digital object ever tested so far. However, according to Fuji, it passes only 2 out of their 24 tests. So the discrepancies are huge. And this is really problematic, and it's frustrating for all of the agencies who want to demand fairness because they no longer have a reliable way of measuring it. But then you ask yourself, well, okay, but which one is correct? Well, of course, people will game the system. Right? The one that gives you the best score is the correct one. Right? But is that going to satisfy reviewers? Is it going to satisfy agencies or editors? And will it satisfy businesses who want to purchase tools and software that claim to be fair, but they have no way of knowing if they spend the tens or 20,000 euros on buying this tool or the software, this device, is it actually fair?
We have one more question.
Okay.
It says, hello, Mark, thank you for the great presentation. I'm Ian, father of a child who lives with a rare disease. Patients and their caregivers and also stakeholders. How has the FAIR team promoted collaboration with patient partners inside the research project? Did their presence bring positive things?
Oh, I wish we had time to talk about that in detail. So yesterday, no, 2 days ago, I was speaking at a rare disease FAIR conference, giving a demonstration of how we're going to combine a patient's own data, which they have full access to, with global data that has been aggregated so they can see their own data in context of other patients who are, as we said, in the same boat as me. And so I gave a demo of that just 2 days ago. And the patients are very excited. They are helping to guide, in fact, they're helping to guide the questions that we're going to ask. So yeah, it is exciting things are happening. Next
There is another question.
Do you use blockchain or protocols? No, we don't. Okay, so I want to talk about the European Open Science Cloud Task Force, and the European Open Science Cloud Task Force was in part established, or at least the Task Force on Fair Metrics and Data Quality was in part established to address this problem. So the charter of the task force says, you know, what we want you to do is do a comparison of tools and identify their biases. Right? Why is this happening? So we needed to check the implementation of the metrics, establish some quantitative criteria for determining what is and is not fair, and then look at the measurement tools. And here are some of the measurement tools that we invited to participate with us. Figure out why they're giving different answers. So the curators of the automated assessment tools came together over 4 sessions. So there was 2 workshops where we defined the problem, and then 2 hackathons where we tried to solve it. And we were discussing the basis for the differences in fair measurements. And we decided that the very first thing we had to deal with was this complexity of metadata discovery and harvesting. So you remember that diagram I showed you a while ago, which is loopy, loopy, loopy all over the place. The problem was that the metadata harvesting for each of the assessment tools was doing it differently. So it was actually impossible to compare even identical tests because they were testing different substrates. So now we're going to go on to a different topic, which is related, but we'll go into now the problem of metadata discovery so I can show you how difficult this problem is. And we're going to start with a single common example, which is a DOI. So you all have seen DOIs, but you probably haven't seen how you get metadata from a DOI. So this is the pathway. You start with a DOI and you ask DataCite to give you structured metadata, and you have to know a priori that this is the question that you ask. And you go to DataCite, and DataCite then gives you structured metadata. You then go back again and you you pass it to datasite, and then you say, okay, give me default, which is star/star. Give me the default. Datasite then redirects you to wherever the endpoint of that, that DOI is. In this case, it's a record in Zenodo. And this is called a landing page. So what you're seeing here is a landing page. Behind the landing page, if you look at what the machine sees, there's embedded metadata inside of that landing page also, which is only partially overlapping with the metadata that you get from datasite. So there's some overlap, but not complete overlap. And if you look carefully at how they're providing the metadata, they're using what are called typed links. So you have a link, its relationship to the thing that you're looking at is an alternate, and then it gives you the address of that link. Now, if you look at the documentation for typed links, the definition is that an alternate keyword is used with type to indicate that the reference document is a reformulation of the current document in the specified format. So then you have to ask yourself, is this CSV file a reformulation of that entire record? And I would say, no, it's not. Right? So there's ambiguity in how we're using these standards. So a metadata harvester has to guess what to do at many steps. There's partial overlap between datasite source metadata and Zenodo metadata. If they're in conflict, what do you do? Right. The use of typed links is also leaving some ambiguity. The interpretation of the landing page itself is ambiguous. So some DOIs resolve directly to the data record. In the case that we just looked at, it resolves to a landing page. So what does the DOI represent? Does the DOI represent that landing page, or does it represent the data that the landing page is about? And that is really confusing for machines when they're trying to interpret metadata because of the context of the landing page. You see author, and you say, well, is that the author of the landing page or the author of the data? And you don't know, and a machine can't resolve that by itself. Really importantly, there's no way to support provider source metadata. So metadata from the person who generated the data, which is the most important metadata, and there's no way to support that. And this is just one example, right? So this is the DOI. There are many dozens of different ways to publish metadata, and they all have these ambiguities. And this is critical, right? So many of you may have thought about the long tail of participation. So in Twitter, for example, the popularity of a tweet, you'll have a few small tweets that are very, very popular, and then a lot of tweets that have no interaction at all. In the context of data, we have the same thing. So if you look at, on this axis, the number of records in a repository, and then the providers that have that number of records along the x-axis, you have a few at one end, right, that have a lot, and a lot at the other end that have a little. And if you look at this breakpoint, on the right side is an equal amount of data to on the left side. So on this side, you have the EMBLs, the Uniprots, the NCBIs, and the Zenodos, and on the other side, way out here, you have my lab with our polyadenylation site database for rice. So those to the left are pretty good metadata providers generally, right? EBI, EMBL EBI knows what they're doing for the most part. Those to the right have considerably less experience, both in metadata collection, metadata standards, and in publishing metadata. And we can't afford half the world's data to be invisible. We just can't. Right? And I think Genome BC will agree with me. That's probably why you're having these seminars at all. So we need to define a harmonized approach to publishing metadata that will support all publishers, both large and small, support computational agents that are exploring these publishers, be unambiguous, and work on all types of digital object. And most importantly, it has to be able to provide access to the metadata from the data creator themselves. So the decision from the EOSC task force and from these hackathons was to use a technology called fair signposting. Now, we decided that three things are necessary for successful traversal of a fair record. You have to have an ambiguous identification of the globally unique identifier, an ambiguous identification of the metadata, and an ambiguous identification of the data records that are described by that metadata. And so we used this technology of links that that I showed you earlier, but we defined a subset of link relations that can address all three of these requirements and do so unambiguously. So again, I'm going to show you the authorship because I didn't do this myself. So quickly scan over those names. And now we'll go on to what fair signposting is. So we chose three link relations. One is cite as, and this is a one-to-one relationship between the entity and its globally unique identifier. We use a relation called described by, which is a one-to-many relationship between the entity and all known metadata records about that entity. And then item, which is a one-to-many relationship between an entity that represents a deposit and the data files in that deposit. Importantly, the links can appear in two different places. If it's a landing page, for example, you put it in the HTML. If it's not a landing page, it's some other kind of digital object, a workflow, a piece of software, an image, a movie, you can put links into the headers of the HTTP message so that they are passed along with the digital object itself. So we can use link relations in signposting in every situation. What it looks like then is you have a starting point. So you do a web search, you have a bookmark, do a DOI resolution without any of the fuss. You just resolve it or any other kind of ID and you get to the final target. In this case, again, a landing page. Under this fair signposting paradigm, inside of that landing page, you have links. You have a relation called cite as, which gives you the globally unique identifier for the data deposit. You have a link which is described by, which is the explicit URL that will generate the structured metadata record from DataCite. And then you have links which point to the individual items that are in that deposit. So now the purpose of landing pages is unambiguous. Landing pages have one purpose and only one purpose, and that is to broker all other entities that are being pointed at from a fair record. Better yet, I can now point inwards to a piece of metadata describing the context within which these data records were generated. So here we're using a technology called RO-Crate, which I will talk to briefly in the next 5 minutes. But this is lovely. I encourage you to look at this spec deeply because it's the first time I've seen a way to do it. Right? Similarly, if you arrive at a non-HTML digital object, a non-landing page, you look up into the headers of the message itself, and in the headers you'll find the same kinds of links. Most importantly, this is speaking to the professionalism of fair testing. We now have a benchmark environment where we have 34 benchmark tests against which all evaluators must test themselves to prove that they're all interpreting this standard in exactly the same way. We have positive examples, negative examples, and all evaluation tools must now challenge themselves to prove that they are operating correctly. Now, I want to talk about this critical metadata, the contextual information behind a data set. And you have to get it from the only source that has it, which is the person who created the data in the first place. Right. So until recently, there were very few standards to support this, and even fewer repositories that focused on making that easily findable, accessible. Journals such as Scientific Data and GigaScience do go out of their way to support this, but most repositories have not defined a clear way to do it. So we had, excuse my typo, experimental metadata formats such as is-a-tab were available, but even when available, they were not advertised by the repositories, so they were approximately invisible to automated agents. So RO-Crates, I'll talk about just briefly. It's gaining traction in the scholarly publishing community, and it's focused on contextual metadata about a data set, what was done, why, using what protocol, with what inputs and what outputs. And the crate aspect refers to the ability to package all of the digital objects. So the data, the workflows that operated on it, the protocols that they followed, and the metadata into a single research object, in fact, even a zip file. RO-Crates can also point outwards. So I can point from my RO-Crate out to GenBank or to Uniprot, and RO-Crates therefore become a point of data federation, and they're using technologies that are familiar to most providers such as JSON and schema.org. The key aspect of the spec is that the entry point for RO-Crate has a specified file name, which means that my agent can unambiguously recognize when it has discovered the entry point for the user-provided metadata. And again, the fair signposting described by can point outwards and inwards to lead the agent to all of that metadata. So there's now a significant incentive, carrots rather than sticks, for researchers to continuously and formally capture their experimental metadata. And this is getting to one of the earlier questions. There's a variety of digital laboratory notebooks. I'm quite fond of the one called Seek. And there's formal metadata, formal capture of materials and methods via protocols.io, which is a fairly complicated tool, but you get used to it after a while. But we need more of a carrot, right? We need the agencies and governance bodies and leadership to consider data publications as important as peer-reviewed papers. And if they become so reusable, they will be as important as peer-reviewed papers. So this will provide the incentive for researchers to adopt unfamiliar practices to make FAIR part of their daily activity. And my own institute has committed to formal daily metadata capture, and we're running a pilot with 3 labs now that are going to use Seek as their daily laboratory notebook to explicitly capture every aspect of their work. So my personal opinions on the next steps for FAIR, getting to the end, there's a lot at stake for FAIR stakeholders, right? They're going to be judged on their fairness. So we have to ensure that FAIR is really professional, right? It has to be trustworthy, objective, valid, and achievable. And to do this, all stakeholders have to agree on some form of governance. And we have a white paper coming out. Here's the authorship of the white paper coming out of the EOSC task force. That should be available in the next week or 2. They're just formatting it in the EOSC publication format. And that's going to include an invitation to join a founding stakeholders group that will establish a charter and continuity plan for a governance body. What could it look like? Well, it's hard to say. So top down, you get to the question, who's at the top? Who is trusted as an arm's length third party with sufficient knowledge to judge fairness? Could it be bottom up, community driven, stakeholder driven? Well, stakeholders have vested interests. And I saw that when we were trying to design the original metrics with the committee. Will they sufficiently agree? And isn't that what we already have? Right? So maybe bottom up will work, maybe not, maybe mixed. So the W3C has an interesting model where members are vetted, members of committees are vetted, but they do allow new membership. So you have this constant turnover of members on different specialist committees. And then we get to the final question, which is testing the only thing we need governance over, or should we be governing the principles themselves? And projects like the FAIR for Research software project from the RDA suggests that the existing principles might not be sufficient for these other kinds of digital objects. So that brings me to the end. I've acknowledged already my numerous and treasured collaborators and co-authors. So now I just want to acknowledge my own institute, the CBGP, my my University Polytechnica, and our affiliated institutes, INEA and CSIC, also the European Open Science Cloud, and the GoFair organization who were hosting the workshops and the hackathons on behalf of the task force. So now let me open the questions. Are these principles applied when you put data on networks or while you perform the research project? So at the end, I'm suggesting that you apply the principles in parallel with your data generation. You have to catch the metadata at the moment you create the data, or else you're going to forget it. Right? And so you can't collect metadata at the end of the month. You have to make it an ongoing process. And formal capture of metadata is not natural for a researcher. They're used to taking handwritten notes in their notebooks. Formal capture of metadata is a different animal, and it is going to take the carrot of having your hard work acknowledged, in as much as a peer-reviewed paper is acknowledged. That carrot is going to be required to get people to change their behaviors and take the time to do this formal metadata capture. So that's my answer to that question to Brahim.
Thank you so much, Mark. I wanted to say 2 things. The protocols.io is actually available to through Genome BC for people who want to use it. And as you were talking about the carrot, Mark, I was wondering, as a funding agency at Genome BC, Genome Canada, all the genome centers in Canada, how we could make it more appealing for researchers to do this work. Because as you said, unless you do it from the beginning, when you start your research to capture the metadata, is very difficult. So is there something that we could do to create some kind of template, or how do we guide the researchers to be able to do this project?
So I'm going to be a little bit cheeky. Right? So and this is Baron speaking, not me. So Baron talks about silverbacks, the people who've been in research for so long that they cannot change their habits. So I would say start with the new lab members, incoming PhD students, get them started, make it a requirement. So the lab head makes it a requirement that they must do this, right? And the motivation is, I mean, scientific data requires formal metadata records. Scientific data is a Nature journal. So the motivation is you get a Nature paper, or at least one of the Nature group papers, if you do a good job of metadata capture. So there is incentive to do this. But I think you have to start with the young people, get them to not get into bad habits, get into good habits right away. And they're also very comfortable with these kinds of interfaces. I mean, so I think that's how you start. As I said, we're doing a pilot right now in my institute to see if we can be successful in getting the entire institute to adopt these behaviors. There's a need for hands-on workshop. I agree. Being confronted with protocols.io and being confronted with Seek for the first time is daunting. So I agree that watching somebody else do it is important. So I have some slide decks for Seek. I don't yet have slide decks for protocols.io, but I've been asked to create them. So that's sort of on my to-do list for the early in the new year. And of course, I'll share those with Zsuzsa.
Awesome, that would be great. Thank you.
Where do I start? Where do I start to make sure I can make my data fair? As I say, that the most important aspect of fair is metadata. So make sure that you are recording in a formal way all of the activities that led to the creation of a data set. And I know that you're going to be writing in a lab notebook, but have a look at a more formal, so protocols.io, for example, right? If you have invented a protocol that you're using that has value outside of your own lab, when you publish in protocols.io, you have a DOI for your protocol that you can put into a site that can be cited, right? So you can get cited for your protocols. So we're sort of, the fair world is a lot about reuse.
Thank you, Mark, because you've just ended this by making some really relevant point for Genome BC. You have really, because that's what we are trying to do as a funding granting agency that works perhaps a little bit more closely with our scientific ecosystem than others. We have really begun to ask ourselves the question, we also need to do something about it. It's not just the investigator and the lab head responsibility. We also have a responsibility as we fund the generation of most of the data for which we are asking, you know, the ecosystem to make fair. And we have a really nice partnership with, hopefully there will be a press release in the next few days with Protocol.io, where we have begun to at least motivate some of our community to use this. And it has been very difficult, Mark, to actually I don't want to use the word convince, but really sort of explain the actual utility. People are worried and scared of sharing their protocol, when in fact Protocol.io makes it easy for you to own that protocol and get the credit for it, as well as making it easy for us as a granting agency to track the impacts. So it's thank you.
It's my pleasure. I think, again, I think it's up to the agencies and the governance bodies to give enough credit to the difficulty of capturing metadata, capturing protocols, and making them public and making them reusable, that has to be something that is worth it to your career. Otherwise, they won't do it.
Sounds good. So maybe that's in line with being able to give an award if you've done really well in sharing your data and your metadata is captured perfectly.
Thank you.
Thank you so much, Mark. I'm conscious of the time. We're already past 10 o'clock and I see that the people are signing off. They have other meetings. Really appreciate it. And, you know, for a hands-on workshop, maybe that's something that we should discuss to be done in the future for next year.
Be a pleasure. Yeah, be a pleasure.
Thank you so much. Bye.
Okay, thank you.
Thank you, everyone, for attending.